translations. And translation, all it means is just we're moving the function. We're shifting it. So we're going to shift. You're going to hear the word shift. And we're going to shift vertically or horizontally. That's all it means. And translations are just part of transformations. So specifically today, we'll talk about quadratic functions, and then we'll look at some other functions. We'll look at how the graphs look. So again, we're just moving, we're shifting, we're not translating. Not like in a language where you translate, like Klingon to English. We're not doing that. All right, so again, just looking at it, we have vertical going up and down, so we can shift up or down, or horizontal, we can shift left or right. That's all we're going to be doing. That's what translations are. So let's look at a rough quadratic. All right, we're going to look at that first. Again, it's just a rough graph here we're going to draw, just roughly. And we have right in the vertexes at 0, 0. Let's look that up a little bit so you see it. There we go. So here the vertex is at 0, 0, and this function is a quadratic function, and we're going to say it's f of x, function of x, equals x squared. That's something to always remember. F of x equals x squared, it looks like this. All right, and if you look at this symbol here, again, there's the vertex is at 0, 0, and this looks, it kind of looks like psi. The Greek letter psi, right? Not psi, meaning per square inch, but psi. So, or, you know, maybe if you really use your imagination, it looks like Poseidon's trident, something like that. Whatever the case may be, if you just remember, it's right there, and that is the equation for it. We can move on from there. And you'll see that a lot. So let's say that this is the function, and this is the parent function. In other words, this is the beginning function, the original function, the parent function. You're going to hear that a lot too. Parent function, right? So let's say we have another equation now that we want to translate this. And we'll just use g of x. And you'll see that a lot also. They'll use f of x, g of x, h of x, I of x. You don't usually see I of x, but then you'll see j of x and so forth. So let's say we have g of x, and let's say I said equals x squared plus 3. So here we have the x squared part, and now we're saying plus 3. So we're going to shift, we're going to translate, right? And when you see a plus sign, we go up. Simple as that. When you see a plus sign, shift it up. So we're going to shift it up. So let's say 1, 2, 3. We're going to shift it up from 0, 3 spaces. So this is where it'll be. That'll be the new vertex. And again, this is just a rough graph. Here we have it. That's where we would shift it. That's where we would translate it. That's where it's moved. Right, so you can imagine then if I gave you h of x, let's say it was x squared minus 4. It doesn't matter. So again, this is the parent function. What should we do with the minus 4? Shift it down. That's it. Right? And there we go. Boom. We're done. So again, when you see x squared plus something or minus something, it's a vertical shift. This is the vertical shift. All right, so here we have a negative function. So if you remember, right, we have a positive is a smiley face. That's positive, but that is a negative is a frown. So that's easy to remember. So erase that. So here we're going to have, let's say we have f of x, and we're saying negative x squared now. Right, and then we'll get our frown. So we could shift this up and down again the same way. So let's say we take g of x, and again, don't get caught up on whether it's g of x or h of x or whatever. Normally what follows f of x is g of x. And we've got the equal sign over there. Let's put that equal sign. Let's not forget that. All right, so if we're looking at this, right, it's the same thing. We're doing exactly the same thing. We have a negative x squared, so we have our frown, and it says minus 5. So we shift down. That's it. So we'll say 1, 2, 3, 4, 5. There we go. Boom. There's our shift. So again, when you see an x squared and a minus or a plus afterwards, that's a vertical shift. Now let's look at a horizontal shift. All right, so here again, we'll just use the parent function we have, right? And you should know by now if you saw this on a test, I asked you what this was. And you're not going to say, well, it looks like psi. Well, you could, for extra credit maybe. But you'll say, well, it's f of x equals x squared. And then I give you, let's say I give you j of x. It doesn't matter, right? Whatever. J of x. Just, I'm giving you another function. I want you to shift it. So what if I say then, and I put parentheses, x minus 3 squared. Now, anytime you see parentheses, you're going to do horizontal. You're doing a horizontal shift, horizontal, right? And again, we're going to go left, we're going to go right. Right? Now, when you see in here, you have to do the opposite of what you think you would do. Now, normally people say, well, they see a minus 3, so we should go left. No. When you see a minus, go right. And let me explain why. So let's just say you had y, doesn't matter, and we said x minus 3 squared. Remember, quadratics have to be set to 0. So how can I get 0 over here? What do I need x to be to give me 0? I would need 3. 3 minus 3 is 0, and 0 squared is 0. I would need a positive 3. So that's why we're shifting, when we see a negative, to the right. That's why. So I'll erase this. So we're going to shift 1, 2, 3, right? Boom. There we go. You're done. So again, when you see parentheses, horizontal shift. When you see, so if let's say it was this, let's say we had f of x equals x squared again, and then I gave you h of x, doesn't matter, and I gave you x plus 4 squared. Well, which way is this shifting? Well, first of all, it's shifting left or right. It's horizontal because it has the parentheses. And it will shift left. It'll shift to the left. So this one over here would be 1, 1, 2, 3, 4. It'd be over here. There you go. Now we have a bunch of psi's, right? Greek letter psi. All right, so again, let's just review. I'll give you a function. You tell me if it's going to be vertical or horizontal. We'll start from there. So let's say I had f of x. You know, it equals x squared. And I gave you g of x. And I said x squared minus 9. What would that be? You don't see parentheses, right? No parentheses. So this will be vertical. Vertical. Right. And are we going up or are we going down? Well, it's negative, right? So we're going down. Vertical down. Simple as that. And what if I had h of x and I said x squared plus 2? What is that? Again, it's vertical. Right? It looks like a U. Let's fix that. Make a V. There we go. But this time it's up. Vertical up. And if I gave you j of x, why not? And I said in parentheses x plus 2 squared, what are we doing with that? Well, we know it's horizontal. We'll just put h for horizontal. And it will be to the left. All right? And again, let's say we did k of x, put in a k of x, and we said x minus 2 squared. Well, what are we doing with that? Again, that's horizontal. And this time, you got it, to the right. So that's translations. Right there and then. All right, time to erase. Now I want to just show you some rough graphs of other functions, just rough ones, and we'll do them in other videos. So if you see something like this, if I ask you what type of graph that is, well, that's just a square root function. That's the square root function, and we'll do them again in other videos. All right, keep that. What if I gave you y equals the absolute value of x? Well, what do you think it is? Fix that line there. That's just an absolute value function, and again, it makes a v, the absolute value function. And again, we'll go over that in other videos. And let's do another rough one. Why not? And if I gave you, let's say, y equals 1 over x, what type of function is that? Well, you should remember that you should never have an x, right, as for a linear equation, because it'll be undefined. So it'll break apart. So if you looked at this, and we've studied these before, you will create a hyperbola. A hyperbola. So this is the reciprocal function hyperbola, and you're going to create a hyperbola. That's what they look like. I'll write it over here. So it's a hyperbola. It is you might hear some people say hyperbola, but don't cringe when you hear that. And we'll just do one more. There are a few others we'll talk about in other videos. And if you see something like this, right, this will be y equals x cubed. So we'll do all those other ones in other videos, and we'll also talk about the other transformations. There are other transformations. This one was just translation. Again, there's reflection, rotation, and there's dilation also we'll talk about. All right, great job.